Hello, and welcome to another Ansys Workbench tutorial. In this tutorial, we are going to solve a combined loading problem. The most difficult part about combined loading problems is determining what needs to be modeled and what doesn't, as well as the boundary conditions needed to give the desired results. We will discuss how to properly do this. We'll use and build a model to compute stresses and deflections, as well as reaction loads. We will also use the model to compute and plot shear moment diagrams. The problem we are going to solve consists of a hand crank that is used to lift a 100-pound load as shown. A person is to turn the hand crank and wrap the cable around the end disc, which then lifts the 100-pound load. There's also a 50-pound load in the vertical direction and a 20-pound load in the horizontal direction applied to the end of the handle. We will analyze the system in the position shown. The dimensions are given in terms of inches. Bearings are located at A and B. Bearing A is a radial bearing and bearing B is a radial thrust bearing. Bearings can carry radial loads, and so these bearings will fix the displacement of the shaft in the transverse or radial direction. Bearing B will also carry an axial load. The focus of this model is to determine stresses and deflections in the shaft. We are not concerned with the end disc. Therefore, we can model the hand crank as a single continuous beam as shown. Here's the handle, the lever arm down to the main crankshaft, and then out to the applied load. This simplifies the geometry because beam elements can be used to model the whole system instead of needing to couple beam and shell elements or beam and solid elements together. The boundary conditions are also as shown, where this radial bearing will provide zero displacement in the X, Y, and Z directions, as does this radial thrust bearing. The end handle will be fixed in the Z direction to counteract the transverse load that's applied here at the end of the shaft. I hope you enjoy the tutorial. After opening SpaceClaim, the first thing I'll do is change the units. The default is metric, and I want to use English units in this model. So I'll left-click File, click SpaceClaim Options, click on Units. I'll leave it as this document only, and I'll change the type from metric to imperial. Inches is the default. I'll scroll to the bottom and I'll change the minor grid spacing from 1/8 of an inch to 0.1, and the number of grid lines per major I'll change from 8 to 10, and then click OK. I then right click and left click on Select New Sketch Plane and highlight the XY plane and click Plan View. I'm now ready to begin to draw my structure. I will start at the origin and build the structure to the right. So I'll come up and click on the line tool, click on the origin and release, and move my line over, and this first line will be 10 inches. So enter 10. Then I can, without clicking, move my line over and enter in another 10-inch line. And now I enter in a 5-inch line. And now going in the vertical direction, I will enter in an 8-inch line. And then I can hit my Control key and my middle mouse button and drag my structure over more to the center, release that, move my line over and type in 5-inch line there. I now have the major part of my shaft is designed, and I can now continue by entering in the line for the circular disc. So I will middle mouse button and rotate my structure. Now I can right click and select New Sketch Plane, and I'll select the XZ plane as shown. Now I can rotate this and come up to my line tool and click on my line tool, go to my origin again, and I will drag this line out and type in 4 inches. I am now ready to create my cross sections, so I can escape out of this by clicking twice on escape. Then I come up to prepare, then profiles, click on my circular profile, and I can see that it has generated beam profiles over here. I open that tree, come over to circle and right click on circle, then left click edit beam profile. Then I click on ruler dimension, and I can click on the 0 and type in 0.5 inches, which is the diameter, or excuse me, the radius of the shaft. So I'll type in 0.5, enter. Now I come down and I click on the Design 1 tab down on the bottom to take me back to my beams, and I click on the structure tree. Then I come up to curves and I click on display, or excuse me, design, and then I come over to select and I click on the top line, shift click the bottom line, then I come back to prepare and then click on create, and I have now created those beams, and the lines that I did have changed to beams. I can come over here to display and click the drop down and click on solid beams, and I can see the solid beams, and I can rotate that around. If I want to see the full solid structure, I click on design and then 3D mode, and I can see all of my beams and I can see their connections. I now need to tell Ansys Mechanical that these beams will be connected to each other. To do that, I come up to beams and I will click on the first beam, and to do this I will need to first click on select. So then I hit select, I'll click on the first beam and then shift click the bottom beam, right click, and then I'll click on move to new component. I can type a new component name in. I'll type in beam, enter. Then I click on that component and I come down to the properties and I change the share topology from none to merge, and that will merge all of these beams together. I've now created my structure in Space Claim. I'm ready to minimize this window and open Ansys Mechanical. After opening Mechanical, it's a little bit hard to see your structure sometimes. And so what I'll do is come over to the structure tree and open up geometry and click on the geometry, and it turns color and it makes it a little bit easier to see. I can see that my geometry has been brought in as one beam with a circular cross section. If I forget, sometimes this will help remind me about the units, because I can see here that my units are given in terms of meters. So I'll come up to the toolbar, click on units, and change the units from metric to US customary in inches. And now I have changed my units. I can come over and close my geometry, and I can see that I have green checks by my materials, my cross sections, and my coordinate systems. So I'm ready to go ahead and mesh my structure. So I'll click on mesh, and then I'll click on mesh context and click generate. And I can see that my mesh has been generated. If I want to change the mesh resolution, I can come down here to sizing in the details of my mesh and change the resolution. The default is 2. I already have it set on 4, so I'll go ahead and leave this as my mesh. I'm now ready to apply my boundary conditions, so I'll come to static structural, click on that, and then I will click on displacement to enter in my first displacement boundary condition. And I will click on the vertex selector and scroll along my structure until my vertices are highlighted. And there's my first vertex, which represents bearing A. So I'll click on that, come over and click Apply, and then I'll enter in the boundary conditions of 0 displacements in all directions at this boundary. So 0, enter, 0, enter, and 0, enter. My next boundary condition will be another displacement boundary, so I'll click on displacement. This is displacement number 2. I'll select the vertex at bearing B and click on it, and I'll click Apply. And then I will also put in 0 boundary conditions, or the 0 boundary condition for each of the directions in the X, Y, and Z planes. I have one more displacement boundary condition that I will apply. It's up at the handle, so I will click on the displacement boundary condition, come over and select the handle vertex, come over and click Apply, and this I will only fix in the Z direction. And this Z direction boundary condition is to resist the vertical load out here on the end of the beam that is causing this whole system to twist. So a Z boundary condition here will let me determine the reaction load that will hold the system in equilibrium. So I'll click a 0 for the Z boundary condition and then click Enter. Since it might get a little bit confusing, I can come up and change the names of these boundary conditions. So I'll click on the first one, displacement, and then when I click the F2 button on my keyboard, it will let me change the name, and I can type in bearing A. Then I can click on displacement 2. This represents bearing B, so I'll click the F2 button on my keyboard and type in bearing B. My displacement 3 boundary condition was my handle, so I'll click on displacement 3, click the F2 button on my keyboard, and type in handle. I've now named those boundary conditions, and it makes it a little bit easier to review them. I now need to apply my loads, so I will come up to Loads and click on Loads, and I can see that I can apply all of these different loads. But I'm simply going to apply a force, so I'll click on the force button, come to my vertex out on the end of my simulated disk and click it, then click Apply, and then I'll change the defined by from vector to defined by components, and I'll enter in a -100 for the load. When I click Enter, I can see that I have -100 pounds force. This is a good way to check to make sure that you also are in the right units. I can now come over and apply the handle forces. So I'll click on the handle vertex, come up and click on force. Then I'll come over and click on apply for the geometry. I'll click the vector to change it to components. And here I will enter in a -50 in the X, or a -20 in the X, and a -50 in the Y, and a 0 in the Z. And so I now have that force there. And I can come and change the names of those forces if I want to as well. I can now scroll through and check my boundary conditions at bearing A. I have this vertex fixed. The components are 0, 0, 0. Bearing B, I have the displacement component 0, 0, and 0. And then up here at the handle, I have a 0 in the Z direction and free in X and Y. I'm now ready to select the outputs, so I'll click on Solution. And if I come up to the stresses and click the drop down for the stresses, I see that everything is grayed out, and that's because I only have beam elements in my model. So I need to come over and enter in a beam tool, and I do that by clicking the drop down on the tool. After inserting the beam tool, I can come over to the project tree and open up the beam tool and see that the direct stress and the minimum and maximum combined stresses are computed by default. To compute the reaction loads, I need to enter in a probe. So I come up to the solution, right-click, insert, and scroll down to probe, and then scroll down to force reaction. And it's asking me over here for the boundary condition where I want that forced reaction, and I'll type in bearing A. I'll do the same thing by coming up to solution, right-clicking, insert, probe, force reaction, and now I'll enter in bearing B. And then one more for the handle, so right-click on solution, insert, scroll down to probe, scroll down to force reaction, and enter in the handle. I now have the forced reactions at the two bearings and at the handle. I can come up and click on the first forced reaction, click the F2 on my keyboard and type in bearing A, click the force reaction 2, click F2 on my keyboard and type in bearing B, and then click force reaction 3, F2 on my keyboard, and handle. So I now have those named. I now want to look at putting in a shear moment diagram. To create a shear moment diagram, I first have to create a path along which the shear moment diagram will be created or computed. To do that, I come up to Model, and I right-click on Model and Insert, and then Construction Geometry and Path. Then I come down to Path, and I change the path type from 2 points to Edge. And then I come and pick the lines that I want to be in my shear moment diagram. So I'll click on the Edge Select tool, I'll click the first line, Control-click the second line, and Control-click the third line, come over to No Selection, and click Apply. And I now have the 3 edges along which my shear moment diagram will be computed. I now come down to Solution again. I come to Solution again, and I right-click on Solution, Insert, and I come down to Beam Results, and I come down to Shear Moment Diagram. And now it's asking for a path. I left the name of the path up above, so I just need to click on the yellow box, click the drop down, and select Path. And then I want to come down, and right now it's giving me the total shear moment diagram. I want to click on that box and look at the YZ component, so I'll click on that component. Then I need to do the same thing, so I'll right-click on Solution again, Insert, and come down to Beam Results and Shear Moment Diagram. I'll click on the Path window to enter in the path, and then I'll click on the shear moment diagram to be in the Z-plane. So I now have my 2 shear moment diagrams about the 2 planes. I have a beam tool with the direct and maximum and minimum combined stresses, and I have my reaction loads at bearing A, bearing B, and on the handle. So I'm ready to go ahead and do a solve. So clicking on Solve, my solution is generated, and I can see that it's processing down here. My cursor was left on the shear moment diagram, so immediately after the solve, my first shear moment diagram opens up. Here's my shear, and I can see I come along with 0 shear, and then I jump up to my maximum of 50, drop down and come across. I can see the associated moment diagram, and it actually gives me the displacement as well. I can look at my other shear moment diagram and correlate that to my hand calculations. I can come down and look at my reaction forces at bearing A, and I can see that my reaction forces are 0 in the X, Y is 166, and minus 50 in the Z, and those compare to my hand calculations as well. In this model, we changed bearing A and bearing B, and we had them both as radial thrust bearings. And so if I look at bearing B, the axial load carried in the x direction of the 20 pounds is carried at that boundary, and I can see that there. I can look at my stress results, and I can see that my maximum combined or my minimum combined stresses where they occur, and I can see my maximum combined stresses occur here at the bending that happens around bearing A, which also correlates to my hand calculations. I hope you've enjoyed this tutorial. Thanks for watching.